This is example one. This is also one of the first problems in the online. We're going to try and perform a one-way ANOVA test. So the question asks, can we conclude that the means, that at least one mean is different? Okay, so let's go through our steps. First thing we need to do is figure out where the claim is. HO for one-way ANOVA tests will always be that they're equal, not variances. So this should be means. Okay, all the means are equal, and sometimes they'll list them out. U1, the mean of the first value, is equal to U2 or mu2 and mu3. Okay, but I just have it right here as they have all equal means. Sorry. Okay, HA. I'm not restarting this video. These take so long anyways already. Anyways, okay, here we go. HO, at least one mean is different, and this happens to be where our claim is. So the critical value, how do you get the critical value? Let's go back to the problem. So the critical value, I'm going to quit out of here. I've already entered the data. Math, push up, numeric solver. Okay, so the critical value. The first number is going to be the number of column or samples minus 1. So it's 2 in this case. Okay, the second column is the total number of actual samples. How do you word that? The total number of the sum, there we go, the sum of the sample sizes. So they have 4 here, 5 here, 4 here, so that's 9, that's 13. And then minus how many samples there are. So it's 10. So there's a total of 13 altogether. And we subtract out 1 for each of the columns. So 10, right? Okay. Now, down here, these all happen to be right-tailed. I haven't gone through all the problems, but I can't see a time when they're going to be left-tailed or even two-tailed. So we just put in the alpha value divided by, not divided by 2. Just put in the 1 minus the alpha value. There we go. Okay, so in this problem, our critical value is 7.56. Now let's find this test statistic. Okay, for the test statistic, you go to test, go to tests, go to ANOVA. Oh wait, before that, you got to make sure you enter your values in. So here's L1, L2, L3. So I already have them entered. Once you have that in, you go to test, test, ANOVA, go L1, comma, L2, comma, L3, okay, hit enter. What did I do? Oh, I didn't put a comma. Make sure, students, you put a comma. There we go. Okay, so we got an F value of 1.5. If you turn the page, if you're on page 562, that's exactly what the book got also. So here we go. We got a test statistic of 1.5. Our test statistic is less than our critical F value. If it was greater than, if it's less than or equal to, we fail to reject. If it's greater than, we're going to reject. So we're less than or equal to. We're going to fail to reject HO. Our claim is with HA, so not enough evidence to support the claim that there is at least one that is different.